Good day, everyone. My name is Rudrev, and it is my honor to welcome you to the session titled From Detection to First Response of Wildfires with Automated Drones. Today, we will explore the innovative use of DOC and drone technology in forest fire detection and response, a subject that is increasingly vital as climate change escalates wildfire risks worldwide. I invite you all to briefly share in the chat where you are joining from and what interests you about the integration of drone technology in wildfire management. Your inputs will definitely help enrich this session. Before we dive into our content, let me outline a few housekeeping rules. To share your general comments or observations, kindly use the chat section. You may also use the Q&A feature for your questions. Towards the end, we will have a dedicated segment to address your queries. The session is being recorded and the recording will be made available within 24 hours. If you encounter any connectivity issues during the session, a quick browser refresh may help. I also encourage you to visit the UAVonic booth at the scheduled time to explore more about the innovative solutions. The booth timing is after a couple of hours from now. Additionally, we would like to extend the conversation beyond today's session. If the content of the session resonates with you, please consider posting about it on LinkedIn. You can tag Flightbase and use hashtag NestGen to connect with others who are passionate about drone technology. I would also like to take a moment to extend our sincere gratitude to our partners who have made this event possible. First, a special thanks to our media partner, Commercial UAV News, for helping us reach a broader audience within the drone community. I would also like to thank our digital spotlight sponsors, AVSS and Fly Freely, for their innovative contributions and continued support. And finally, a big thank you to our broadcast sponsors, UAVonic, Droneland, and Drone Nerds, for enabling us to bring this session to all of you. Thank you for your continued support. It is now my pleasure to introduce our distinguished speaker, Mr. Mishal Severa, CEO of UAVonic. With extensive hands-on experience in implementing automated drone systems for critical infrastructure, Mishal brings a wealth of expertise from his work across forestry, construction, energy, and public safety sectors. Today, Mishal will share insights from real-world deployment, illustrating the tangible benefits of deploying DOC drones for forest fire detection and response. Without further ado, I now invite Mishal and his colleague, Miroslav Chongradi, to present and to take the stage and present and share the tangible benefits of deploying DOC drones for forest fire detection and response. Thank you for joining us, and I trust you will find this presentation both informative and inspiring. Mishal, the stage is yours.
Good morning, everybody. I would like to start my presentation, and I try to share my screen. I hope it will work now. Okay, so the topic is quite important in this moment. We just saw some wildfires in California a few weeks ago, so everybody now understands what the wildfires can do. And I'm happy that I get the opportunity to cooperate with military forest in Slovakia and prepare this kind of presentation about our experience, how to manage the response to wildfires. Shortly about UAVonic. UAVonic is a company which is leading provider of drone technologies. We are mostly focused on the aerial technologies, providing drone-based solution for construction, energy, and industrial application. Over the years, we developed expertise in drone integration and automation and data collection. We are based in Bratislava and in Slovak Republic and serving mostly Slovak and Czech market. Here you can see a nice picture of our office in Bratislava. Our mission is to improve the efficiency of safety and precision in area operation. We work with businesses and government agencies to incorporate advanced drone systems into their workflow. As an official partner of Flightbase, we focus on providing secure and intelligent automatic solution for enterprise. We had also several experience with integration sensors to drones, data integration to develop specific GIS application. One of our key services is methane detection for gas distribution company. This is something special in Slovak and Czech market. About the DJI Dog brings another possibility, so we focus into area in drone in the box system. This fully automated drone system enables now 24/7 operation with minimum human intervention. And today I will show how to use these technologies for wildfire detection. Drone in box brings new possibility like remote operation, automated mission performance, but also new challenges regarding safety and coordination in airspace. Shortly about military forest. We call it VLM, which is shortcut from the Slovak name of company. VLM is a state-owned company responsible for managing extensive forest and agricultural land within the military training area. With significant area, about 63,000 hectares, VLM operates through the 4 region branches. Understanding their operation is crucial as we explore how to drone technology can enhance their management practices. VLM has taken significant step by integrating an autonomous drone system to bolster monitoring and security in Záhorie military district. On the map, you can see the area covering 27,000 hectares. Has been a key military training space since 1950. The implementation of drone technology here is not only enhance security, but also improve operational efficiency in monitoring vast landscape. Okay, wildfires. Okay, sorry. Now let's take about wildfire situation in Záhorie, in a region of western Slovakia. This area is covered by large pine forest, which are highly flammable. Combining with dry condition and strong wind, the risk of wildfires is extremely high. Historical data reveals that a larger scale fire have caused significant damage in this region. Understanding this factor is essential for developing effective prevention and response strategies. On the right side, you can see some pictures or some video from extinguishing the wildfire. And on the next slide, we will speak briefly about 3 major events or incident caused by wildfire in Slovakia. In 1992, we have a larger wildfire in Slovakia. In this time, it was burned about 1,171 hectares in this region. In 2007, there was a 3-hectare forest destroyed, and in 2012 was another 200 of pine forest burned. The main disadvantage of this wildfire in this area is that we have a lot of sand here, and this pine forest, which is very quickly burning. So it's really challenge to fight with this kind of fires. So the problem is clear. Wildfire needs to detect early to prevent major destruction. If the wildfire start to rise and be bigger, then usually we do not have enough sources to fight with the fire. So we need to be quickly in detection and react also very quickly. What are the traditional methods for detecting the wildfire? We can use satellites, we can use some towers, and of course we have to rely also on the citizen reports. Of course, there are some limitation in these technologies. Satellite-based technology is nice. It's a large scale. It's helping to track the fire, but usually it's not so accessible for the people who are managing the fire. And of course, there are some obstruction due to visibilities, and it's limited for early warning. Lookout towers are good solution, but of course they have a limitation in the way of area which you can cover. In the past, they rely mostly on the human observation. Now there are several projects where the human observation is replaced by modern technology like cameras, air detection, and so on. But still, it's limited with the area which can cover this lookout tower. Citizens reports are very helpful. They can be quick, but especially in this flat area where we are placed in West Slovakia, sometimes when you observe forest, first you have to look on yourself, because if you observe the wildfire, usually you are too close, and first you have to take care about your life, and then trying to contact the firefighters and give the information about the location. What are the firefighters' challenges? It's really to have very quick and accurate information from the people, and we think that implementing drones in this decision making is very helpful, because we have to understand that the spread of the fire can be very quick, and the response, the rapid response is essential for managing the fire. So, what is the solution? We have to solution. It's automated drone. We believe that it can help. So let's deep dive a little bit to drones as a tool for managing the wildfire. Drone give us view from the top from the sky, so we have very quickly the response. How big is the fire? What is the direction of the fire, and so on. So it gives us more possibility how to react. If we connect it with the automated drone missions, then we have a system which can regularly repeat the mission, give us a regular picture, and detect the fire very soon. Okay, what kind of drones we can use? There are several drones which are relevant to this to wildfire management. We can use fixed wing drones. We can use multi-rotor drone. We can use some hybrid drones. That means VTOLs and so on. Drones like this. But all the standard approach with the drones means that we are starting the drones if something happened. Automated drones have the main difference that the drones are flying regularly, so we have big chance that we will identify the fire in the start. Okay, what help us with the advanced with the detection? Maybe 10 years ago, we was happy that we can place some thermal camera on the drone. We have to use big drones, sometimes over 10 kilos, just to implement some thermal camera and some good visual camera. Now, if we can use the small drones like Mavic 3DT or now new Matrix 4. These are very small drones which can be operated from any place. They are very small and give us a lot of possibilities. Of course, they are also significantly cheaper. So the thermal camera is really the key point for detecting the heat anomalies. Then we can use some AI analysis. We can use satellite data, which can help us, and also we can use IoT sensor. But we believe that drones and AI detection is the most advanced technology which we can use now for accurate wildfire detection. Okay, drone in the box is nice concept. It's a significant advancement in automated wildfire response. With the future like autonomous launch, landing, this system ensures 24/7 readiness and for immediate deployment when the fire risks are detected. In the key benefits in of the drone in the box concept is emphasizing its potential for rapid and effective wildfire management. I'm never tired of watching the drone, the takeoff and land into automatic box. It's nice to see how the drone is fighting with the wind to keep the right position to land precisely. This is really not boring image, and I like it. Until now, we have addressed in our drone business. The cybersecurity was something what we have to take to consideration, but it was more in relation to data processing, protecting of our infrastructure. However, as we move towards fully autonomous drone in the box operation, cybersecurity become a critical factor in ensuring the safe and reliable drone missions. Drone not only collect sensitive data, but also operating in complex environments where the security threat, such as hacking and data breaches, pose significant risk. Flight-based on-premise provide a key solution for safeguarding autonomous drone operation. Okay. A little bit missed in my notes. In August last year, we conducted initial tests over several days to evaluate the actual radio signal and range and collect large amount of video and photo footage to verify optimal flight parameters. We had pleasant 35 plus degree Celsius in the shade, also in this pine forest. There wasn't too much shade to begin with. Only the real test show you how is written only based on the real test. You can check what is written in the technical specification. We was happy that VLM asked us for this test, and we perform it to show them that really the DJI dock and Flightbase is the right solution to implement it into a regular operation. All the land managed by the VLM falls within restricted airspace, as you can see on the right side on the map, which bring the specific requirement for the drone operation. It is not just about communication with ATC, but also with other military units that may conduct the training exercise in the area. Test flights are not only way to verify whether the assumption of the technical specification hold up in the real condition. How far we have to answer a lot of questions. How far I can fly? Will the drone retool if lose the signal? If the power fails, will the drone do what it's supposed to do? What happens if the connection between the dock and the server is interrupted? There are simple, never enough testing. For example, we initially expect that charging would be the biggest limitation in performing repetitive mission. However, as we discover when using Starlink and the Flightbase cloud, we couldn't upload data fast enough to move all the collected data to the cloud platform. Why we do keep talking about the 2 to 2.5 kilometer radius where the specification state 15 kilometers range radio range? The answer is simple. 15 kilometers is theoretical maximum under ideal condition based on FCC standard. However, in Europe, we follow the which allows us use lower transmission power, reducing the maximum range to 8 kilometers. Additionally, since the dock station is on the ground level and the trees naturally obstruct the signal, realistic operation range is about 2 kilometers. Sure, we could place the docking station in higher position on some tower, but this would limit the drone's operation capabilities. The DJI dock has maximum wind tolerance during takeoff and landing for wind about 8 meters per second, but it can fly up to 12 it can fly in the wind up to 12 meters per second. Keeping the dock on the ground reduce the restriction caused by strong wind, ensuring the more reliable operation. And of course, we believe that new DJI DRTK will help us to increase the operation range with the function of a relay station. Here is the key user requirement from VLM, and it was the custom map. As you can see, the map include a lot of colors, a lot of numbers, and this is the identification of each forest parcel, and based on their management, they understand that under each number, it's a history of the management of the forest, and also what are the plans with the forest in this area. So if VLM would like to include the dock into standard operation, they would like to manage also the flies based on their organization of the parcels. Okay, IT security challenges. Honestly say, this is the nightmare of the on-premise installation, IT security. It feels like being catch between two milestones. On the side, customers closed and the high security system. On the other hand, flight base with their expectation, strict IT security requirements, and well-protected infrastructure in VLM, and at the same time, habits of developers and their own vision of implementation. This is the main challenge of the implementation. The network architecture was designed to keep the individual components separate while allowing for future system expansion. It was crucial to ensure that the system could be universally controlled from any of the customer's location. The basic diagram may look simple, but within the concept of the entire network infrastructure, it posed a significant challenge during the installation. Beyond visual line of sight operation in VLM, restricted airspace come with the specific operation limits. The maximum flight altitude is 120 meters above the ground level, which is ensuring the compliance with the airspace regulation while still providing good coverage. The operation radius is from 2 to 3 kilometers from the DJI Dock 2, allowing the drone to cover the significant area without exceeding the communication limits. Using advanced sensors like thermal camera and good zoom cameras, increase the total monitored area extent up to 5 kilometers. These include optical and thermal imaging capabilities for precise wildfire detection and situation awareness. These parameters define the safe and effective operation of the system within restricted airspace, ensuring reliable monitoring while staying within the regulatory requirements. Operating BVLOS in restricted airspace present several challenges, particularly in airspace coordination and communication with different authorities. First, we have to must have clearance and maintain real-time communication with Malacky ATC. Since we are flying in controller airspace, every flight must be coordinated to avoid conflicts with main aircraft. This means continuous update and approval before each mission. Altitude limitation also play a role because we are flying at low altitudes, terrain and dense forest canopy can interfere with operation, make it precise planning essential. Another major challenge is signal and connectivity. At extent distances, maintaining a stable communication link within the drone and within the drone is critical. Any losses of communication could impact the mission, so we need robust and reliable infrastructure. Beyond that, there are additional airspace restrictions to consider. There is a LZR 314 is an active airspace restricted that extend from ground level and overlaps within drone flight altitude. This means we need to coordinate every mission carefully to avoid any interference. There is a firing range called Zuzana, operates in the same altitude zone, meaning the drones must be synchronized with military training activities to prevent the conflicts. These make communication with not just ATC, but also with the military units absolutely essential. With proper coordination, operation in restricted airspace will be not possible. That's why we are working closely with all relevant authority, and it's a key part of BVLOS implementation. Okay, conclusion and next steps. AI detection. In this time to have presentation without AI, it's absolutely nonsense. So I also part about AI detection. Implementing machine learning from real fire and smoke detection reduce reliance on human monitoring, making detection faster and more efficient. However, where AI process where AI processing happen is crucial. Live stream video is compressed to maintain range and minimize the drone control or delays. If AI is applied only after the data exists DJI dock, it can process video in HD or even and in good condition, full HD quality, leading to more accurate fire detection. The M3TD drone records the 4K videos in visual spectrum and 640 to 512 pixels thermal footage. But there are some limitations, like we can transmit only one stream, and this is challenging to implement good AI tools. Of course, we can use the AI tools for full 4K videos, but this is not real-time analysis because the 4K videos are only available after the download to dock and then upload to the server. So we have to rely on the HD quality for the AI analysis, and also with the limitation that if the operator switch from a visual camera to thermal camera, then also the stream which have to be processed is different. But we take the AI as a next steps for our project. What are the key takeaways from the deployment? We approved that DJI dock with M3TD has proven valuable for continuous aerial surveillance. We are still in finding successful airspace regulation. We have some frame for testing and this pilot operation, but still we have a lot of to do with the national authorities. And the next steps is, of course, the automation and AI integration, where we see big potential of this project. Okay, that's all from my side, and I look forward for the talks and questions. And I now try to switch back to the live view. Okay, thanks.
Thank you, Michelle, for this very insightful presentation. I open the floor to questions now. I am looking at the Q&A section, and we do have a few questions. So let me start with the question received first, which is, so I'll just translate that question for you. And the question is that given the area over which VLM operates, or in general, the forested areas are quite huge, for the purpose of forest fire detection, does the rescue service have the budget for using a lot of dock-based drones, or is fixed wing a more reasonable option? So it's basically a comparison between fixed wing and DJI dock and drones for forest fire monitoring over an extended period. So do you have any thoughts on that?
Based on our cooperation with VLM, we have to understand a little bit different position why VLM considered to use DJI dock. VLM is not VLM is a company who is managing the forest, so they decide that of course if they have to manage this huge area with a lot of challenges, the DJI dock can be helpful, and the financing, the implementation of the DJI dock is based on the budget of VLM. Of course, they have relation with the firefighters located in Malacky and in the whole region, but the monitoring is done within the VLM organization, and if something happens, based on their operational procedure, they start communication with the firefighters and and they are then initiating the firefighters' response to the wildfire.
Okay, thank you for that. I have another question from Christina, which is regarding the operating temperature ranges for the dock. So, have you faced any challenges with operating during high temperature or during snowy conditions? What has been your experience?
Based on our experience in our climate condition, the temperature range which allowed us to operate the drone are sufficient. Of course, if you have a very hot weather in the summer, you have to calculate with a little bit longer time for charging the batteries, because the drone when lands first should be cooled, and of course there is air condition inside, but you cannot simply charge batteries which are very hot. And in the winter condition, the low temperature, of course, make two challenges. First is the freezing on the propellers. This is something what we have to still fight somehow with this. And second is not the low temperature, but mostly the strong wind, especially for the landing and takeoff. When we have wind which is more than 12 meters per second, simply we cannot start the drone.
Understood. Thank you for explaining that. I have a couple more questions. So one of them is, so have the forest rangers adjusted to using drones instead of fire towers, and what do they think about this change?
Okay. We are using the drones here that they are in dedicated places and operated from one place. We are slowly preparing also some operation center in VLM, which will take all the operation in one place. So in the future, we expect that there will be several dock station, and there will be a central control room for all of these 4 areas which are operated by VLM.
Okay.
So
And the
not
last question.
dedicated only for West Slovakia, but also for the rest of the Slovakia where VLM is operating.
Okay. And the last question that we have is, what was your biggest challenge during this project with VLM? Was it
Uh,
logistics? Was it, the deployment of on-premise? What has been the biggest challenge so far?
as I mentioned, the communication with flight-based development team and the IT guys from VLM, and quite strict conditions regarding security and information which can be uh, on one side from VLM. Of course, they cannot provide us with very detailed information about their infrastructure. And on our side, I understand that VLM, the flight-based developer, has also some knowledge which cannot be just simply distribute. And finding this right communication and right place for the implementation, it's really the crucial point.
Okay, so to summarize, integration of dock drones in a high security environment has been the biggest challenge.
Yeah,
Okay, all right. Um, Thank you
we
very
we
much.
have to understand. We have to understand that VLM is state of company, but their owner is Ministry of Defense, so they have
Yes.
to follow all the military standards regarding the IT security. So this is the crucial point.
All right. Okay. Thank you very much, Michelle, for your for the presentation, for your answers to the questions. And as we conclude today's session, I would like to thank everyone for their participation. I hope you found this session inspiring, and it would encourage you to explore further applications of automated drone systems, not just for forest management, but also for other applications. And thank you all for joining us today.
Thank you.